Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hakimi bin Muhammad Jamin. From my part, from PBL of Met Engineering, I will introduce about the problem statement. The first question is about a population. This is figure 1 about the image of radium. Uh, the question is about it is found out that in 30 years, 1.32% of a certain amount of radium decomposes in the air at the rate proportional to the amount of present. The question is determine approximately how long it will take for one half of the region amount to decompose. Okay, about the second question is about a figure 2 thermometer in a room. It's about a Newton law. The question is about temperature of a room is 22 degrees Celsius. A thermometer reading 12.2 degrees Celsius is brought into the room. 45 seconds later, the thermometer reading is 15.2 degrees Celsius. Okay, the question about this question is how long does it take until the reading becomes 80 degrees Celsius? That's all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Sufi bin Muhammad Safri, and I will talk about filler table on question 1. So the problem statement, it is found out that in 30 years, 1.32% of certain amount of radium decomposes in the air at the rate proportional to the amount of present. Determine approximately how long it will take for one half of the origin amount to decompose. Facts. Number 1, 1.32% of certain amount of radium decompose in the air in 30 years. Number 2, 1.32% of certain amount of radium decomposes in the air at the rate proportional to the amount of present. Ideas. First, we solve the equation of rate proportional. Number 2, find the amount remaining after time t. Number 3 is insert the value into the equation. Number 4, find the value of k. Number 5, insert the value of k into the equation. And number 6, find time it takes to 0.5 A to decomposes in air. Learning issues. Number 1, what is the formula to answer the equation? Number 2, how to use integration correctly. Number 3, how to extract information properly from a question. Number 4, when to use integration. Resources needed. Number 1, internet. Number 2, books. Number 3, calculator. And last one is discuss with group members. Thank you.
Bismillahirrahmanirrahim. So my name is Muhammad Niafka Biusran. So now I would like to continue our presentation by presenting about filler table. So problem statement. The temperature of a room is 22 degrees Celsius. The thermometer reading 12.12 degrees Celsius is brought into the room 45 seconds later. The thermometer reading is 15.2 degrees Celsius. How long does it take until the reading become 18 degrees Celsius? Fact. Number 1, temperature of a room is 22 degrees Celsius. Number 2, a thermometer reading when brought into the room is 12.2 degrees Celsius. Ideas. Number 1, the temperature increased by time. Number 2, the current temperature try to adjust the room temperature. Learning issue. How long the thermometer take time to become 18 degrees Celsius? Resources needed. First, internet. Second, library books and engineering mathematic books. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Adi Akmal and I will present about the solution of radium half-life. So the formula of the radium half-life is dx over dt equal to negative kx. X equal xo exponent negative kt. So from the question we got t is equal to t and x is 100% minus 1.32% xo. And answer is we got 0.9868. So we substitute into the formula. 0.9868 XO equal to XO exponent the power of negative 30k. Exponent negative k equal to 0.9868 the power of 1 over 30. So the answer we got for the x is x equal to 0.9868 the power of t over 30 XO. The x is also equal to 0.5 or 1 over 2 XO. So we substitute 0.5 XO into the x, and we got a 0.5 XO equal to 0.9868 the power of t over 30 XO. Then we change it the friction, and we get a 0.5 the power of 30 equal to 0.9868 of the power of t. We learn all the number, and to get the t, so we learn it t equal to t learn 0.5 learn 0.9868. So the answer is t equal 1564.91 year. That's all for me. Thank you.
Bismillahirrahmanirrahim. My name is Muhammad Adi Zuhair bin Jasmani. Now I will talk about the solution about the thermometer in a room. The room temperature is about 22 degrees Celsius and the thermometer reading is 12.2 degrees Celsius. Now it's brought to the room. After 45 seconds later, the thermometer reading is 15.2 degrees Celsius. We need to find time, how long does it take for the thermometer reading become 18 degrees Celsius. We will use the equation, which is temperature reading equal to temperature initial plus delta temperature times 1 minus exponent power of negative t over t. 15.2 equal to 12.2 plus 9.8 times 1 over minus exponent negative 45 over t. Now we will transfer the 12.2 to the left side, which we will get 3 equal to 9.8 times 1 minus exponent negative 45 over t. Then we will change the 9.8 to the left side, which will get 0.3061 equal to 1 minus exponent negative 45 over t. We change the side of exponent negative 45 over t to become positive, which we get exponent negative 40 power of negative 45 over t equal to 0.6939. After that, we will get negative 45 over t equal to negative ln 0.6939. After we will eliminate the negative, then we need to find the t equal to 45 over 0.3654, which we will get t equal to 123.15. After that, we submit the new information, which the thermometer reading become 18 degrees Celsius. 18 equal to 12.2 plus 9.8 times 1 minus exponent power of negative t over t. Then we will get 5.8 equal to 9.8 times 1 minus exponential power of negative t over t. After that, we will get 0.5918 equal to 1 minus exponential power of negative t over t. After that, we get exponential power of negative t over t equal to 0.4082. We need to eliminate the exponent, then we get negative t over t equal to negative ln 0.4082. After that, after we eliminate the negative, we will get t equal to 0.8960 times t, which we get from before. T is equal to 123.15. We will times the 0.8960 with times with 123.15, which we get 110.34 second. After that, we will make into the minute, which is t equal to 1 minute and 50 seconds. That's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I will continue about the conclusion of the question. The first is about population. In conclusion, the first question answered by using a integration, solve the rate proportional, and both of the side equation we were integrated. Next, the value of integrated were inserted into the value of x. Then the value of x we inserted in the equation before, and it will become 0.9866 x0 equal x0. Refer to the questions. Question want to find how long will it take for 1/2 of the reagent amount to decompose. With that question, we inserted the value of x and find the equation to find about the origin amount to decompose for 30 years. Okay, after that, the equation will become and solve the equation using logarithm method. And the final answer or time to take for 1/2 of the origin amount is t equal 1564.91 year. Okay, it's about population. Second is about the Newton law equation. About this conclusion, we must calculate how long it takes until the reading becomes 80 degrees Celsius. First thing first is we conclude the information in the equation. For the thermometer reading, that is 50.2 degrees Celsius, and for we conclude with 12.2 degrees Celsius. Okay, then we solve the equation. Equation provide the value of t is equal t equal is 123.15 degrees. Next, back to the formula. The equation is probably changed to for find the reading that's become in 80 degrees Celsius. Using the equation, we simplify the equation and become it actually is to find the time, the actual time after the latest equation be like this. It just left to change the t with the equation. It is left a single t of the equation. And lastly, the final answer for how long it take until the reading become 80 degrees Celsius is 1 minute 50 seconds. That's all for me. Thank you.